Welcome back to the Explainer. Today we're jumping right into part 144 of Developer Eng's notes on Haskell programming, and we're looking at a really targeted refactoring of a command line interface. We're going to explore a transition from one data type to another that honestly might sound tiny at first, but the architectural ripples it creates, moving from tangled library-coupled logic to beautifully clean, decoupled code, are absolutely massive. So, you know that old stereotype, right? A lot of developers out there still believe Haskell is just inherently complex, overly academic, and frankly, completely unreadable once you get into real production code. It's a super persistent myth in the engineering community. But today, we're going to completely bust that myth by walking through this real-world refactoring example from Eng. If you've ever felt like your own pipelines were just getting totally out of hand or your business logic was doing way too much heavy lifting for your external libraries, you're definitely going to find this breakdown incredibly useful. All right, let's dive into part one, the setup, the tangled validation problem. The root of all this chaos, it really came down to the original codebase leaning way too hard on the ParserResult type. Initially, the validate_args function took in arguments and returned an IO action containing a parser result. Now, why is that such a big deal? Well, the core problem is that ParserResult is tightly coupled to the internal state of one very specific library, the optparse-applicative parser. By using it this way, Eng's core business logic was literally shackled to the specific internal plumbing of that CLI parser. When you tie your logic directly to a third-party library's state like that, your architecture gets incredibly rigid, you're setting yourself up for potential library lock-in, and writing isolated unit tests, yeah, that becomes nearly impossible. The brilliant pivot here is how Eng standardized the whole CLI pipeline by completely ditching that rigid library-specific parser state and swapping in the clean, generic either type. So instead of that old, messy setup, the new signature returns an IO action containing either string. It's a really elegant paradigm shift. The either type is just structurally superior for this because it cleanly separates your outcomes using its inherent data constructors. Think about it. If there's an error, the function simply returns a generic string message inside the left constructor. If the validation succeeds, it returns your desired arguments perfectly wrapped in the right constructor. This one strategic move is the absolute key to standardizing return types across all the different actions without having to rely on some library-specific failure state. Which brings us to part two, the refactor, swapping to the either type. Making this happen was basically a three-step playbook to finally ditch that library dependency. First, as we just talked about, standardize the return type to either. Second, actively use that shift to completely decouple the validation logic from the parser state, creating a really nice, clean boundary. And third, which is absolutely crucial for both the style and the pure functionality of the code, swap out those complex guard clauses for clean case statements to handle things like file existence, text validation, and encoding checks. In the older version, Eng was using these really complex guard clauses to verify conditions, and honestly, it created quite a headache. Just imagine trying to trace logic that runs checks like isText, which literally grabs a 1024-byte chunk just to look for 0 bytes, and isUTF-8, all jammed into a single guard block. It makes the execution path so incredibly hard to follow and just cumbersome to debug. But by replacing those clunky guards with case statements, the whole flow becomes instantly transparent. You can visually step through the logic naturally and see exactly where the code branches and exactly how the data is moving through the pipeline. And that leads us right into part three, the reveal, simpler, cleaner Haskell code. The payoff for these three steps, it's absolutely undeniable. This serves as ultimate proof that Haskell can in fact be simple and maintainable, and achieved a totally decoupled codebase. Because the validation logic leans entirely on a generic either representation, it's finally free from that parser's internal state. Practically speaking, this means the validation logic could theoretically be reused anywhere in the app, way beyond just the CLI parsing context. The overall codebase is significantly simplified, and without those tangled guard clauses in the way, any developer stepping into the project can easily read, trace, and actually understand the core logic. Eng wraps this all up with a really fantastic reminder from this refactor. It's entirely possible to write simple, readable Haskell code provided you use the right language constructs. By simply rethinking our types and our control flow, we can completely transform rigid, cumbersome programs into clean, generic architecture. Which kind of leaves me wondering, does your current codebase just need the right language constructs to finally become readable? Definitely something to think about the next time you review your own pipelines. Thanks so much for joining me for this explainer, and keep building clean code.